Hello and welcome to the episode 6 of PyTorch Deep Dive. In the last episode, I started explaining workers use with DataLoader. Let's continue in this episode, as I will show what happens when iteration ends and how a worker loop works. We finished showing iteration loop. Let's deep dive to see what happens when the loop ends. When all sent tasks were already received, it's time to stop while loop. Since workers are not persistent, Torch shuts them down at this moment. Firstly, it's checked if it's Python shutdown, which is not the case this time. Next, internal shutdown flag is checked not to double shutdown logic. No pinned memory, so this branch is skipped. Iterator sets shared done event to signal the workers. Then, for each worker that is still known as active, it's marked as unavailable. These are sanity checks about shutdown status. We take the queue assigned to the worker, this time to worker 0, and put none into it. This will signal worker loop to stop listening on index queue. We set internal worker availability state to false, so we see worker 0 is inactive anymore. This is repeated for every worker. Next, there is 5 seconds wait period for each worker to quit gracefully. After this, each worker index queue is closed. The final block removes signal handlers, and at the very end, it checks if any worker process is still alive, and if not, it's explicitly terminated. Once this is completed, stop iteration is raised, so the loop can terminate. This part was about DataLoader process. Let's see what happens in a worker process. I set number of workers to 1 for better debugging experience. Once the worker process is started, worker loop function is executed. It starts with setting thread properties. The first important thing is to set seed for each worker. Worker seed is a combination of base seed and worker index. Each worker will get different seed, and Python random, Torch, and NumPy random are initialized with that seed. Each worker stores global worker info object with basic worker information and environment. If init function is specified by the user, it's called at this step. In our case, it's none, but passing such function allows to customize or align worker state at this very moment. Create fetcher was discussed in my previous video. Watchdog object stores state of the project. In Linux, it checks if ID of parent process is changed. If this happens, it means that DataLoader process terminated. The loop is active as long as watchdog alive flag is set. Index queue is queried for batch data. In this case, we received batch indexes for task of index 0. If result is none and the done event was set, the worker loop stops. Then fetcher is queried for the data. Once the batch data is ready, the result is stored in the data queue along with the task index. The data is deleted after it's being put into queue. If exception is raised by fetcher, it's being wrapped and sent back to the data loader process through the same queue. Once the data loader work is done, data queue is closed. In this video, I showed how multiprocessing is used to support concept of multiple workers that speeds up data loader work. In the next video, I will show how neural network module is designed in PyTorch. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.